We saw how matter can be classified according to state, whether it's a solid, liquid, or gas, and we've looked at the properties of solids, liquid, and gas at the atomic level. Now, let us classify matter according to composition. And so, matter can either be a pure substance or it could be a mixture. A pure substance is made up of only one type of atom or molecule, and it could be further subdivided into an element or a compound. Now, an element is found on the periodic table, and an example of this is iron and nails. Nails are made up of pure iron, which has the chemical symbol Fe, and we will learn about that later, but iron is found on the periodic table, so it is a pure substance and it is an element. A compound is a combination of those elements, so that are chemically bonded. So it's a combination of elements that are chemically bonded, and that is a key point there. So when we have H2O or water, we know that it's chemically bonded like so. So we have oxygen, an element that's found on the periodic table, and hydrogen, but they're chemically bonded, and they repeat in order. So they are repeating units. So in a glass of water, you will have many of these repeating units. Of course, a glass of pure water without minerals. Now, a mixture, on the other hand, is composed of two or more different substances in variable composition. So we have a mixture can either be homogeneous or heterogeneous. And homogeneous mixtures are the same throughout, which means that, for example, in air, we have a combination of different compounds and elements. So we could have oxygen, nitrogen, argon, carbon dioxide. As you can see, each of these are either an element or a compound, but we have a mixture of those. But it is a homogeneous mixture. It's uniform throughout, which means if I take one breath of air, I'm consistently going to be getting the same ratio of oxygen to nitrogen to argon to carbon dioxide in each breath that I take, practically anywhere in the building that I'm sitting in. But a heterogeneous mixture, it's not going to be uniform throughout. Like if you had oil and water, oil is going to sit on the top and water is going to sit on the bottom. And so if you take a sample of this, if you happen to take a sample from the top layer, it's going to have oil, and if you take a sample from the lower layer, it's going to have water. So you see that the mixture is not uniform throughout, and we have two or more substances. So we've talked about classifying matter according to composition. And so we're going to do an example to see if we've learned the concept. Classify each type of matter as a pure substance or a mixture. If it is a pure substance, classify as an element or compound. If it is a mixture, classify it as homogeneous or heterogeneous. I want you to keep thinking back to the flow chart that we just did. Take a picture of the flow chart in your head to help you classify this. So for A, we have a lead weight, and since it's just lead in that particular set of weights, then it is a pure substance. Now the next question we want to ask ourselves, is it an element or a compound? Well, lead can be found on the periodic table. That's what you want to ask yourself. Lead has the chemical symbol Pb, or for just now, look at the name, lead, because we will learn the chemical symbols and the names later. But since we find it on the periodic table, it is an element. Now for seawater, is seawater made up of one type of thing, or a mixture of things, more than one substance? Well, I would say it has more than one substance in it. Seawater can have salt, water, minerals, and other things. So I'm going to say mixture. But I want to say, is it homogeneous or heterogeneous now? Is seawater uniform throughout? If you were to take a sample from the shore, it's going to be most likely consistent with the sample if you drove your boat and took a sample in the middle of the sea. So I'm going to say it's homogeneous. It's relatively uniform throughout. Now, distilled water. You might say, what is distilled water? You may or may not know this, but distilled water is something that we use in the lab a lot. It is free of minerals that we find in your normal drinking or tap water. Your tap water has fluoride and all sorts of electrolytes and other things in there. So distilled water is just pure water, which then will mean that it is a pure substance. But now we got to ask ourselves, is it a compound or an element? Well, it's going to be a compound, because water has the chemical symbol H2O, and it's made up of two or more elements that are chemically bonded. As for Italian salad dressing, it's definitely a mixture, because we have a lot of stuff swimming around in there. We can physically see it. We can see the Parmesan, the oil, the vinegar floating around. But is it homogeneous or heterogeneous? Generally, what do you have to do when you want to use Italian dressing? Most likely you have to shake it, because it is not uniform throughout. The products may settle down on the bottom, the vinegar and the oil may separate. So it's kind of like our water-oil combination. So it is a heterogeneous mixture. So I want you to go ahead and try this on your own and replay this video to see if you got the correct answers. I want you to classify each type of matter as a pure substance or a mixture. And if it is a pure substance, classify it as an element or compound. If it is a mixture, classify it as homogeneous or heterogeneous. So mercury in a thermometer. It seems we can find mercury on the periodic table of elements. So it's got the chemical symbol Hg, so it must then be a pure substance element. Exhaled air confuses some people sometimes, because we're taught in grade school that we breathe out carbon dioxide. So you might think it's pure carbon dioxide, which is a compound. However, we don't breathe out just carbon dioxide. We breathe out water, moisture, oxygen, nitrogen. So it is really a mixture. However, it is homogeneous throughout. It is consistent. It's not like I can breathe out more carbon dioxide in one breath than the other. It's consistently the same ratio. For minestrone soup, that should be an easy one. it should be a mixture, because you can definitely see that it is got more than one substance in it. So it is heterogeneous though, because it's not consistent throughout. One spoonful of minestrone soup can give you more green beans and red beans. The other one can have green peas and potatoes, for example. So it's not consistent throughout. Sugar is a pure substance when you have sugar only, but it is a compound because you can't find sugar on the periodic table. So it must mean it's made up of more than one element. And here's the chemical formula for sugar, which is glucose. And you can see that it has carbon, hydrogen, and oxygen, but it is in repeating units. So it is a compound. The carbon, hydrogen, and oxygen are bonded to each other in a certain ratio, and then they repeat in units, and that is our definition of a compound.